Assalamualaikum warahmatullahi wabarakatuh. We continue beam analysis using moment distribution method. Okay, let's consider this beam. Okay, we have pin, roller, roller, fix. Pin, roller, roller, fix. So we have A, B, C and D. Okay, B to C, it has uniformly distributed load. Okay, A to B, point load. Okay, so here the point load value is 150 kilonewton and UDL is 45 kilonewton per meter. The length of each member, okay, like this is AB is about 4 meter, 2 and 2, 2 meter, 2 meter. And then B to C is 4 meter and C to D is about 3 meter. Okay, now we are going to analyze this beam, analyze the member and moment. Okay, we will analyze member and moment using moment distribution method. Okay, so we will analyze this beam. Okay, this beam has a constant EI. So we just said the beam has constant EI. This is EI. This is also EI. This is also EI. So this beam has constant EI. So we are going to analyze this using moment distribution methods where AB, okay, for AB, okay, let's look at the diagram together. A, okay, AB, A is far and pin and pin. Far and pin. For BC, both are internal, and for CD, okay, for CD, D far is far and fixed. Far and fixed. Okay, we have to identify this because we will use this in order to calculate the K value. The K value will be depend on the far end condition. Far end condition. As usual, in order to analyze the beam using moment distribution method, step number one, we will start with calculate the K value. Okay, K value, K for each element or members. Because after that, we will identify or calculate the distribution factor. Distribution factor equal to K divided by total K, or it is also equal to member stiffness divided by joint stiffness. Joint stiffness, distribution factor. Okay, the next step after that is fixed end moment. Fixed end moment, and for this beam, okay, for this beam we have AB. Okay, AB, this is AB fixed, and we have BC both. Okay, we can assume both end are fixed because we are referring to the appendix given. Okay, appendix are given in okay, in chapter number 2, or you can also refer to the appendix in the back page, okay, of the textbook. Actually, okay, there are formula for fixed end moment based on far end condition. However, we can also solve all fixed end moment by first assuming both ends are fixed. Okay, this one point load at the center, and this is UDL. Okay, so for 150, this is 150, 2 meter, 2 meter. Okay, the moment. Okay, we need to calculate the moment. Assume both and fixed doesn't matter. Okay, later on I will show to you what if we consider the far end condition in calculating the fixed end moment, and then we will compare the result. Okay, so this is fixed end moment, also fixed end moment for UDL. For UDL, we have here 45 kilonewton per meter. This is 45 kilonewton per meter and 4 meter. Okay. And after that we have to put distribution factor. Okay, distribution factor and FEM we have to put into the table. We have to put into the table, and we will start calculate the end moment using in the table. Okay, using moment distribution process. Okay. Okay, let's do it together. So I want to calculate all the value in the table form straight away. So I will move this to Excel right now. Okay. So we move to Excel. We have. Okay, so there are 3 members. Remember, 3 members will bring us 6 member, and moment start from AB, BA, BC, CB, CD, DC. There are all 6. Okay, ABBA for element number 1, member AB, BCCB for element number 2, member BC, and CDDC for element number 3, element number 3, member CD. Okay, so for this beam, okay, this beam has 4 joint A, and then joint B. Remember, the moment that we distribute is actually the joint moment, which is opposite with member end moment. And the fixed end moment is actually the first member end moment in the table. But the moment that we distribute is actually the joint moment, which is opposite with member end moment. Okay, so we will start first putting the. Okay, calculate K first. So K. So this is K in terms of EI, because EI is constant. EI will be cancelled whenever we calculate distribution factor. So I will just put EI outside like this. And okay, for calculating the stiffness factor, we need to consider far end condition. Far end condition. Okay, wait. Okay, for calculating K, we need to calculate K based on far end condition. Okay, for end condition, if we refer back to this, for AB, far end is spin, so we need to use 3 EI over L. 3 EI over L, so I put like this, it is 3 EI over L is 4 meter. And it is the same for ABBA, because it is actually the same member. Okay, now we will calculate the stiffness factor for BC. for member BC, so both BC and CB will have the same value. So since both are internal support, so we will use for and fixed formula. Okay, for and fixed or internal support, internal support. So we will use 4 EI over L. It is 4 EI over 4. It is 4 EI over 4 is equal to 1. Doesn't matter. Okay, like this. Okay, the last value CD for member CD. So KCD, KCB is actually the same value. Okay, by looking at the diagram for and fixed, D is fixed, so we have to use 4 EI over L. It is 4 EI over 3. This is 4 divided by 3. 4 divided by 3. It is, sorry. This is just equal to this one. Okay, format. It is number. It's number. Okay, I want to set 3 decimal places. Okay, 3 decimal places. Okay, next after calculating K, the second step is to calculate distribution factor, and distribution factor is member stiffness divided by joint stiffness. Okay, member stiffness divided by joint stiffness. However, we need to put the distribution factor at, okay, NA is pin and D is fixed. Okay, NA is fixed and D is, NA is roller and NA is pin and D is fixed. Okay, so remember that pin, roller, cantilever end, okay, are all end of the support end of structure. So for distribution factor, for pin distribution factor is equal to 0.75 divided by 0.75 because it is the end of the structure. However, for fixed end, distribution factor is equal to 0 since it will be divided by infinity. Okay, so for BA, the total joint stiffness is 1.75. BA plus BC joint stiffness is 1.75. 1.75, this is joint. Okay, joint stiffness, it is 1.75. So we want to calculate to have the factor, the distribution factor for BA. It is 0.75 divided by total. 0.75 plus 1, it is 1.75. So we get 0.428. Okay, and we will do the same for BC. It is 1 divided by 1.75. Okay, so we can set the number up to 3 decimal point. Okay. So we move to joint C. Joint C, the total K for joint C is, okay, total K is 2.333. So for CB, it is 1 divided by 2.333. Okay, it is 1 over 1.333 divided by 1 plus this one. Remember, these two value, when we total back, it will equal to 1. Because distribution factor at each joint is actually equivalent to 1 except fixed end. Because fixed end is not the end of structure, so it will be, the value will be divided by infinity. So distribution factor for fixed end is 0. Okay, so this is this distribution factor. Okay, this is the distribution factor. Okay, so next is we will start putting the first member and moment in the table. The first member and moment in the table, and member and moment is come from fixed and moment, fixed and moment, fixed and moment. Okay, we refer back to this. Okay, we have AB 150 point load. Okay, the length is 4 meters, so we will use PL over 8. PL over 8 for the moment, and the direction, the sign. Okay, the sign for MAB, FEMAB negative because it is opposite with sign convention. Our sign convention is clockwise. Okay, so AB, FEMAB will be negative and BA will be positive. So it is PL over 8. P is 150 times L is 4 divided by 8. Okay, don't forget to put negative. Okay, don't forget to put negative here. And another one will be positive. Okay, next move to BC. WL squared over 12. WL squared over 12. W is 45. L is 4. WL squared over 12. W 45. L 4 2 times. WL squared over 12. So we get negative 60 and positive 60. Positive. And since member CD, okay, the FEM is 0. 0. Okay, so 0 value, we don't need to put into the table. So this is actually the FEM. Okay, FEM. FEM. Okay. So as I mentioned just now, FEM is actually the first end moment in the table, and when we distribute, we actually distribute the join moment, and join moment is always opposite with member and moment. So after this, we will start with the first distribution. The first distribution. Okay, so we will do it one by one. Okay, we will determine now the total moment at joint A. Total moment at joint A. Remember that this 75 is actually, this 75 for AB. For AB is actually member and moment. So joint moment for A is positive 75. Positive 75 because this is fixed end moment. Fixed end moment is member end moment. The moment that we distribute, okay, is actually the joint moment, and joint moment is always opposite with member end moment. And AB, there is only one value for AB. For A, contribute by AB, So it is so in the table, in the Excel, we will put negative to represent the opposite direction of joint moment. Okay, it is we put negative and then we put select this. Okay, select this times with distribution factor. Okay, times with distribution factor. Okay, I put dollar sign like this in order to lock the distribution factor. Lock that position. Okay, so it will equal to 75. Because when we need to check back, when we total these two value, it will equal to 0. 0. Okay, we move to joint B. Joint B, the total moment for joint B, is actually, total this, put negative. Total, it is actually negative 75 and 60. So in order to have that, so we put negative, okay, representing the opposite condition. So we plus these two value. Okay, we need to times with distribution factor 0.429. So I put the dollar sign in order to lock the position. Okay, in order to lock the position. And then I will do the same for BC. I put negative to represent the opposite condition. Total moment 75 plus with this negative 60 times with distribution factor. So I put the dollar sign at the distribution factor in order to lock the position. Okay. So I want to set to decimal, a number up to 3 decimal point only. Okay. So to check whether the value is correct or not, okay, try to plus this 4 value. 75 plus negative 60 plus negative 4.6.429 plus negative 8.571. The total must be equal to 0. Okay, we move to join C. We move to join C. We will repeat the process again. Okay, the total moment is, total moment, join moment is negative 60. It is negative because it is opposite with member and moment. CD doesn't have a value, so it is only come from CB alone. Okay, so it is, so I put the negative, so plus with this. So this is just for the formula, I will select even though the value is 0. Okay, like this. And then times distribution factor. So lock the position for the distribution factor, and I will set the decimal point up to 3. Up to 3. And for CD, there is no value to distribute. Okay, now we have the first distribution here. This is the first distribution. Okay, next after distribution is carry over. Okay, we need to carry the value or carry the value to opposite join. Okay, it must cross boundary. Cross boundary means A to B, B to A. Okay, CD, C to D, D to C. Okay, BC, B to C, C to B, cross boundary. It must cross boundary. But it has factor that we need to consider by looking back at the far end condition. So here, FEM, then we start in the table. So in the table, we will have A, distribution. Okay, distribution. And the next after that is carry over. For carry over, we need to remember that there are two conditions that we need to consider. We need to consider the far end condition, and for far end pin, the factor is 0. Far end pin, the carry over factor is 0, and far end fix, the carry over factor is equal to 0.5. So yang ni pin. Okay, this one fixed. Okay, internal are fixed. So end pin here is actually referring to A only. Referring to this. Okay, referring to this. A only. Okay, so it means that here we need to, okay, just remember like this. We have to cross boundary, means A to A and B, cross boundary means like this. Okay. Okay, B to C, B and C cross boundary like this. C to D cross boundary like this. But remember, the factor is 0 for N pin. So this one is 0. 0. Okay, 0. Here is 0 because N pin 0. However, this 75 we need to carry to B. A to B. B is internal. Internal is fixed. So we will apply COF, carryover factor, equivalent to 0.5. 0.5, it is 75 divided by 2. And then for BC, we will get negative 25 divided by 2. And then for CB, we get from BC negative 8.571 divided by 2. And for DC, doesn't have value. For DC, we get from CD. It is negative 34 divided by 2. Okay, now I want to set the... Okay, here, like this, the decimal places. Okay, now I want to repeat the process again. Okay, by only copy the formula and paste. Okay, I select, I copy, and I paste. Okay, third time. Okay, fourth time. Okay. Distribution number 2, carry over. Distribution number 3, carry over. Distribution number 4, carry over. Distribution number 5, carry over. Okay, we can continue. We can continue again. Copy, distribution, carry over. Copy. Okay, we will stop whenever the value close 0 or reaches 0. 0.00 something like this. Okay, so this one is distribution. And the last one must be, must end. The last value must end at distribution. So this one I clear. Clear content. Clear content. Okay, so here is all the value. So 0, 0, I want to clear as well because we don't need to put 0 in the table. Okay, and then I want to clear the okay, this one I want to clear. Okay, so these are all the value in the table. Okay, these are all the value in the table, and the last value, okay, we must find the summation or the total. Okay, the total moment. Okay, start with the first moment. Remember that the first moment is starts from fixed end moment. So I choose the symbol sum. Symbol sum, and we will get here the end moment. End moment. Number 3 decimal places. Okay, so these are all the answer. All the answer. All the answer. Okay, so this is the answer. Okay, by looking at this, okay, we found that, okay, for BA and BC, since MBA plus MBA plus MBC, MB is actually MB is actually MBA plus MBC. Okay, and it is equal to 0 because of internal, because the roller support at internal. Okay, here, okay, B roller moment is equal to 0, MC is also equal to 0. This is MB, MC is equal to 0. That is why in the table we have whenever we total MBA plus MBC, we get 0. And MCB plus MCD is equal to 0 unless whenever the joint has external moment. Okay, like this. Okay. Okay, so this is all the end moment. So in the next video, I will show to you how if we consider the formula, the fixed end formula, considering far end pin for FEM BA, and how to analyze whenever we consider far end condition for FEM calculation for BA, and we will see whether the value is equivalent with this one. Okay, so that's all for this video. We will meet again in the next video. Assalamualaikum warahmatullahi wabarakatuh.